is Miss Bonner. What's your name, sweetheart? Avia. Pronounce your name for me again. Say it one more time. Baguette. If I mess up your name, blame it on my head, not my heart. I apologize. I'm awful with names. So we're gonna start off with this do now. So this is a review of what you all have already reviewed. We've already went over these lessons. So if you take a look at the first question, you have a graph. I'm asking you to take a look at the graph, identify the excuse me, identify the starting value, identify the growth rate, and then write the equation. And then in the second question, I gave you a tile pattern. I'm asking you to identify both the growth rate and the starting value, and then write the equation again. All right. Need a pencil, sweetheart? I got one for you. I got you. And you didn't tell me your name. What's your name?
Lanaya.
Say that one more time.
Lanaya.
Lanaya?
There you go. I caught one.
Yay! Come on in. The math is mathing in here. Come on.
You got my teacher every other day.
Yes. All this greatness you get to witness.
Hey, girl.
Don't let take a pictures. I know I have to see.
All this greatness.
I think I did this assignment already. I don't think I should do that.
All this greatness.
I'm like, how long?
Home? Why would you want to go home? You're here. Alright, that's okay. Just try your best. I'm gonna project it up here so you can see it, sweetheart, because I ran out of copies. Technology is not my friend.
Yeah, the buzz down the part is bigger.
I think this might be the last one. I am not sure.
You think you can?
Alright, so we're working on this,
I'm
on
not going.
this left side.
Please.
Did it already. We'll do it again. I mean, you gonna walk us through it then. Since you did it already, you already the expert. I got you.
Every time I get in this class, I get sleepy.
Let's hear it.
That's why we're gonna be up today.
Wake it
We're
up.
not just sitting.
Wake it up. We're working on the left side, those two questions. You got it. Since you did it already. What's your name, sweetheart?
Zaria.
Zaria. That's a beautiful name. I almost named my daughter Zoe.
She's pretty. My brother name actually is Zaria, though. My mama said when I was younger, everybody started calling me Zaria because she was good.
Wow.
Oh. Yeah, I almost named my daughter Zoe, but her daddy vetoed it. And so we went with Riley. And she's definitely a Riley. She's definitely a Riley. She's I don't know if y'all watch the Boondocks, but Riley's a character. And my child is definitely a character. Nothing like her gentle, loving mother. She's a character. Two more minutes and then we'll discuss these.
You on this side?
The left side, sweetheart. Over here. I know my little, I don't know why my buckles moved. What the hell thing? Let me move this over. I don't know how to. Thank you.
There's a crow calling. Y'all was gonna sit out there.
Thank you. I need you today. I need you to help me. Help me be great.
Do need you.
I
I just like saw a jump. I should have. How does the bathroom? I should have bathroom downstairs. Ain't the bathroom jump a lot?
I don't know if it's open.
Yeah, jump from Washington. With a smart good stars. How is the bathroom? I'll be right back.
Hurry back.
I'll go on this one.
So we start from 3. That's how we put the variable y with that. What about the other segment? Where did it come from? They just moved in one direction, but you just moved in one direction to go from your 3 to the 5? Yeah, but you moved in just one direction. So you say you went from 3 to 5. Is that the only direction that you moved? You said it went up. Is that the only direction you moved, or did you move in a different direction as well? Okay. Just one more minute, we're gonna discuss.
I think they're the same. I think they're gonna end up being the same. No? No? Let's do.
Like that triangle you drew.
Let's do. But this is figure 1, and I need figure now. So it's how I got back to that. No.
So this is just like school. I got 2 kids that's in the hallways.
Yep.
This is a real mock
It's
lesson.
real life. It's
I
really, really,
I really got
really.
2 kids in 2 kids that's in the hallway. All right, so let's have a discussion about this. All right, let's take a look at question 1. So the first part of the question asks us, well, what is the starting value? So it says, what is the starting value / y-intercept? So what does the word intercept mean?
Ooh,
What does that mean?
you're right. I missed it. You're right.
What does intercept mean? Intercept the x-axis?
Yes.
Okay, what you say?
Either. Catch. Yes.
You don't remember? Alright, let's activate that prior knowledge. Let's remember. So when we talk about intercepting, alright, so y'all watch football at all? Alright, so if somebody threw an interception, is that a good thing or a bad thing?
I don't know, it sounds bad.
It sounds bad, right? That, what happens when the interception happens in a football game? What happens? Y'all don't watch football? Okay, alright.
Cross?
So that's exactly what intercept means. So if we're playing football and we're on opposite teams, right? If I'm the quarterback and my team got the ball, if I throw an interception, that means your team caught the ball that I intended to throw to somebody else. So you was in the spot where I wanted my person to be, and so now your team got the ball. So it's bad for me, good for you, right? But the word intercept means to cross, to touch, to be in that spot where you intended someone else to be. So when we talk about a y-intercept, we're talking about where our graph crossed the y-axis. So show me the y-axis on your graph. What direction is that? What direction does the y-axis go? Up and down. Alright. What's another word for up and down? Say it again. Vertical. Alright, so our y-axis is vertical. Alright, so show me your x-axis on your graph. What direction does it go? Horizontal. And what direction is that? How can we say horizontal is different? Left to right. Alright. So when we talk about y-intercept, we're talking about where do our graph touch that y-axis, that vertical axis. Alright. So what's your starting value? Where does your graph cross your y-axis? Where is that y-intercept? What's the value of that? 3. You say 3? Did you say 3 as well? You identified yours as 3 as well, right? Alright. So if that's our y-axis, that's our starting point. Now, when we talk about, okay, what is the growth rate or that slope triangle, I see you drew your slope triangle, right? And you labeled yours. When we talk about that, we're talking about, okay, well, how does this line grow, right? How does it change? What does that change? So we need to actually add a value to it. So what is that growth rate? 2? Do you agree? I see you got a triangle. So when you say 2, where do you get the 2 from? Okay. What do you do? How do you get your 2? Alright. So you actually drew the actual slope triangle, right? To show, okay, well, what is this change? To go from my initial starting point to the next point on the line, what was my change? So that 2, that change of 2 that you're looking at on your graph, is that a vertical change or a horizontal change? Say it again? Vertical. And you told me you counted what way? What direction did you go? Up, right? So when we talk about that vertical change or change in y, that vertical change is our change in y, right? Say that one more time. What's that great? I'm gonna say it. Rise. She said rise. So when we're talking about this growth, when we're talking about the change of our line to go from one point to the other, we're talking about the actual slope of the line, right? We're talking about that rise, right? Now, is it just rise? Did we just change? Say it again. Rise over run. So she just gave us some great vocabulary terms that we use to describe the slope of a line. Rise over run. You drew the slope triangle, right? So our rise is 2. What is our run in this particular example?
You asking everybody?
Yeah.
Oh, 1.
1. And we're just, show me the 1. Show me the 1 on your graph. And that's a what type of change? Horizontal change. So when we talk about rise over run, when we talk about the growth of our line, when we talk about slope, we're talking about the same measurement, right? We're all talking about the same thing. So now that I'm asking you to write the equation of a line, we need those 2 pieces of information to actually write our equation. So how do we put it together to write the equation? What does the equation of a line look like? What does it look like? Is that a fraction? Good. Say it again. You said something. You said y equal. What did you say? It's okay to speak up. It's okay. It's a safe space. All we're doing here is mathing. So it's okay. It's okay to share. So what would our equation look like? What you write on your thing? Did you write your equation? What you write? Y equals 2x plus 3. What did you write? You got 3y plus 2. Okay. So what made you write it that way? Okay. You see that? Do you agree with what he said? What do you know? You know a lot, because you wrote some stuff on your paper. You put your 3 here, and you said because that was a vertical change, you assigned that y coordinate to it, or that y variable to it. And then you added 2 because that was your change, right? So we'll remember when we're writing the equation on the line, we want to start off, our y-intercept is our starting point, right? And so our equation should always mimic the formula y equals mx plus b. Y'all remember that? Right? So when we talk about y equals mx plus b, what's the m part? What does that mean? Let's talk about that for a second before we jump into the next example. Technology is not my friend, guys. So I'm talking about that. Okay, what you doing? My board looks different. Where's the little whiteboard? There we go. Alright, so when we're talking about the equation of a line, we're talking about y equals mx plus b. What is the m? What is the b? What was the b in your equation? The starting value. So that's our y-intercept, that's our starting value, that's where our line cross our y-axis, right? Now what was the m? The growth, right? Your slope, your growth pattern, your slope. What is that constant change that we're seeing? If I ask you to go to another point on the line, will we see the same growth?
Yeah.
That's what make a line, right? That constant growth, that same slope, that same constant change that we see. All right, so knowing what we know, based on the graph in number 1, let's take a look at number 2, question number 2. I know it says figure 1, figure 2, figure 3, but let's think about it as figure 0, figure 1, and figure 2. I didn't catch that until this morning. Y'all gotta forgive me. I'm old and I was sleepy. So let's go with figure 0, figure 1, figure 2.
She wants
All right.
to see 0, 1, 2. Yep.
So that's our starting part, our starting figure. Let's identify our growth pattern. And then let's write the equation for number 2. And then we're gonna jump into some real fun stuff. We're gonna get, y'all get to get up and move around. How often does that happen in math class? Never? Alright, we're gonna do it today. So we starting with the first figure. How many
I
boxes?
know what I'm doing.
You say you what?
I'm not gonna pretend I know what I'm doing. So wait.
So what we starting with? Let's take a look at the first figure. What we starting with?
I don't even know.
How many boxes?
Figure 0,
How many boxes?
5.
Okay. Well, how many in the next one? So write your 5 down. Cause that's what we starting with, right? Alright. So what's the pattern? What pattern do you see?
Goes like 2.
Okay, so you said the growth is,
Like 2.
okay. Alright, so when we talk about growth pattern in the first problem, where did that show up in our equation?
Right here, this piece of paper.
It did show up right there on that piece of paper. But our equation for the first one was what? Y equals, put the first equation on your paper. Y
Mx
equals, yes. But our exact equation for this one was Y equal, what was it? 2x plus
Y.
3?
I don't know.
Write the equation out. Y equals 2x plus 3. Now, where was the 2? Oh, you wasn't in here when we were talking about it. Where did the 2 show up on this one?
Right here. Yeah, right here.
Well, yeah, it's on our graph, right? The rise. You hear what you're saying? So what do you mean by rise?
Going up.
Going up. So you see how we started here at 3? That's our starting point. You see where 3 show up in our equation? That's our starting point. That's our y-intercept. And so she said our rise was 2. So to go from this point to this point, we had to rise 2. And then go to the right, how many?
1.
1. So you see how the 2 shows up here? So we wrote this 2 as a fraction, because we can write any number as a fraction. That's when we put the number 1, and we see all those values show up in our equation. So now we're looking at it pictorially, right? So we have this image here, where we're starting with, right? You see our progression. You already told me what the growth is, right? But where does that show up in the equation? Okay. So if I ask you to write the equation to represent this situation here, how could you write that? That's the question.
It's supposed to be M. What is it?
What, for 5?
Yeah.
I don't know, what is the 5? Did you start with that, or is that your growth?
That's how we started with it.
We started with it. What did we start with here? Where did we start at here? Really? Did we start at 2? Okay, so if you start at 5 here, but you started at 3 here, where did the 3 show up in your equation? Okay, so where would your 5 show up in this equation? Okay, so make out.
And go about 2 at a time.
Is that what happened? Is that the situation? Is that what we see?
Am I right or wrong?
You are definitely on the right track.
But it's wrong in some way.
No, you're good. I just want you to write it.
I like going back to this all the time. I don't know.
So it's just showing you, it's just a different representation. So don't get caught up in rise and run over here because it's not a graph, so it's not gonna show you the rise and run. So the rise over the run shows you in the growth count. That's why I put the little hints in the little,
But I like the idea that
parentheses.
it's easier to see. Start.
What time of class? We just started. We just having fun. We about to really have some fun. 10:45. What time is it? 10:45. Yeah. So you only gotta deal with me another 45 minutes. You good? So we good on number 2?
Sleeping right there in his class.
You know, wake up. You need to do some jumping jacks. Feel free. Or some burpees if you into those type of things.
No.
All right. So what do we get for our second equation? What do we get for our second equation?
Is it all the same thing? Because every one of these go about 2.
So when we talking about a line, right? So if you go back to this first example, right? So if I give you another point on the line, wouldn't it go up by the same amount? Wouldn't your change, your slope, your rate of change, wouldn't it be constant?
Oh.
Right?
Yeah, I'm done.
So in order for us to write the equation, I have to give you a constant rate of change. So what is our constant rate of change in that second example? 2. Right. What do we start with?
3.
We started where?
3.
What do we start with? No, the first one, the second example. You still on the first one. So
The second.
Oh, 5.
5, right? So what's our equation?
9.
That's our final pattern has 9 boxes, but that's not an equation, right? So our equation we end up with, what do we end up with? 2x plus 5? Alright, so you see how you got yours split? So you're thinking about the components correctly, you just have your equation flipped. So the growth pattern is your slope, right? So the growth pattern, or that growth triangle, like how you drew your triangle and you saw your rise over your run, that's your slope. That's that constant change. So to go from here to here, we added 2, right? To go from here to here, we added 2. So that's our constant rate of change. If I ask you to draw the next figure, how many boxes would it have? If we keep up with the same pattern, how many boxes would the next figure have? 11? How did you get to 11? What you do with the 9? You added 2, right? So we see the pattern, we can identify it. Alright? So we know a whole lot of information right now about linear equations. Alright? We know how to take a look at a graph and come up with the slope. Right? We know how to identify our y-intercept or our starting point. We know how to do that on a graph, and we know how to do it pictorially. So we can look at this particular pattern and identify the constant rate of change, as well as what we started with. And so we can write our equation. So we good on that? We good on writing equations? Yes? I gotta talk to me. Alright. Okay. Now, we're gonna get into some fun stuff today. Alright? Well, it's fun to me because I'm a nerd. I need y'all to be nerds with me today, okay? Just join the nerd club, okay? Listen, so this is sweet. This is a sweet technology. Don't tell nobody. I don't want everybody in here tomorrow talking about we wanna get on that math situation which I was on. So don't tell nobody, okay? This is between us 5, okay? Well, us 8. No, I mean, alright, so look, what we're gonna do today, guys, we're going to use this information that we already know about linear equations, but what we're gonna do is we're gonna create our own line. Alright, so here we got this little motion detector situation. Alright, y'all got security stuff at the crib? When you open the door, say front door, side door. Can you sneak out the house with somebody telling on you, right? So what that is it's a mini version of this. So when your door is closed, the sensor reads it's connected, right? When you open it, it's disconnected, and that's what sends off the message. The front door has been opened, right? So what this does is it detects how far you are away from the little sensor. You hear it ticking? So what it's doing, and let me turn it, I don't know how to turn it up. I'm louder than that, but you hear it ticking. You hear that ticking? Okay. So what that is doing is sending out a pulse, right? It's sending out a little wave to detect how far away I am from it. So what we're gonna do, what you're gonna do, is you're gonna get up and you're gonna create a graph, a line, graphical line, to represent your distance in respect to time, how far you are away from this particular device. And then we're gonna take that line and we're gonna write the equation. Y'all cool with that? Alright, so let's do it. Okay, so now, I've only played with this thing like twice, so, if I mess it up, it's on me. Okay. But we're gonna do it together. Alright, so let's do it. Who wanna go first?
Me.
Alright, let's do it. Alright, come on up. So, let me put the actual question up. So, I didn't realize this was this little. It's tiny. I can barely see it. But this is the question from the actual lesson. So, we had the actual lesson. So, the actual question says, alright, get up, move around, shake your bodies, and we're gonna create some lines by using this particular device. So, we got this little device, we got our calculator, and what the calculator does is it takes your measurements and creates your actual line graph. Alright? So we're gonna create the graph using this technology, and then we're gonna write the equation to the graph. Okay? So, to start off, I'm gonna have you, alright, let's take a look at this one. Look at these tiles. These tiles are like 12 inches, like they're a foot apart, right? They're like a foot square, right? 1 square foot. So I'm gonna have you start. Let's have you start right here. So now the important thing with this machine, you have to be directly in front of it for it to actually read you. So yeah, so it's be good right there. So you are approximately 1, 2, 3, 4, 5, 6, 7 feet away from this device. Alright, so what do y'all think her starting point is? 7 feet, right? That makes sense, that's her starting point. Now she's gonna walk toward the device. Don't walk in, let me start over. Let me start the situation. Alright, I just did this morning. Okay guys, I promise you. I did it this morning. So, that's not.
That's fine, yeah.
Okay. I promise y'all, I really did this morning.
Must have been another morning.
I'm telling you, I did it this morning, today.
She did, I was there.
I was there, I have a whole witness.
I was there, I saw her, she did it successfully.
But this is how technology works, right? When you want it to do what you want it to do, it does what it wants to do.
It's not ready.
Alright, it's not reading anything yet. Okay, so what I want you to do is walk at a constant rate toward the machine. Walk regular. It didn't do it. I'm doing something else. Let me get it.
Oh, Jesus.
There we go.
That sounds like it's doing it.
Now it's reading. You know what, machine? Don't do it like this. Don't do it like this in front of the kids. Alright, okay, let's start again. Alright, go back to it. Listen, when it doesn't work, what you do is a hard reset. That's what you do in life. When your phone don't work, y'all do a hard reset. Up, down, hold the button, power off, swipe, all that good stuff. Alright.
It makes a trace, yeah, we can play around with that.
Alright, let's try it. Alright, we're gonna try it. We're gonna get this to work. Okay, well. Why are you not?
Does it have anything to do with she walking straight towards the sensor? Or just because she's walking kind of
No, it's not, it's doing, it's me.
It's not collecting it?
It's not collecting the data.
Oh, okay.
Alright, so go back to where you were. Okay, hold on, we got some data. Alright.
Probably when she was walking back,
When you
'cause
walk
they let
back.
it go faster.
Right, that's so crazy. Alright, let's
Okay.
pause it. Okay. Okay. Store. And I keep thinking this is touch screen, but it's not. Alright, here we go. Alright. So y'all see how she's standing still? You see how it captured her distance? Y'all see that horizontal line? Alright. So when she walked back, what type of slope does that have? Is that a positive slope?
Oh,
negative
it
slope?
shows like it walk straight.
So this dark line here, for whatever reason, it captured that data. It didn't capture what we wanted to capture, but it captured when you were just standing here. So we have this horizontal line, right? Because, was she moving? No, she was standing right here, right? So her position over the amount of time that it captured the data didn't change. But however, when she walked away from it, when she backed up, you see that line that she created? Can you see it, sweetheart? So this dark line here is when she was just standing still and it was capturing her position, right? But this line here is when she backed up. That little dotted line, it didn't connect it, whatever, for whatever reason, I don't know. So, all right, full disclosure, I learned how to use this using a whole different calculator. Yeah, thank you so much. I'm being completely transparent with y'all. So I usually know what I'm doing when I'm doing it. However, I learned on a different calculator that captures the data a little bit differently. But the whole purpose of this is for us to be able to create a line and then write the equation from it. That's our whole goal. But I promise y'all, I did know what I was doing at some point. However, right now, it's just not working for me.
Do you wanna try the other one?
I think I heard.
Yeah, the other one might work a little better.
Let's try it. Let's try it.
And it may even work better if we go like in the hall. So, or have more space to move.
You really fell for that hot thing.
Girl, that's what you thought.
You fell for it.
Did I?
Like 2 days in a row. You didn't fall for 10, but you fell for it 2 days in a row. What else? That's what else. Huh?
You hit start, right? It should let me go.
Mommy, can we see that again?
Okay. How far is it gonna go?
Oh, I stopped her. Sweet. Capture that.
It does take a minute. That's the only thing I know about that.
Five usually about
And if you do it again.
Don't get a whooping now. I treat my students like y'all my kids. I whoop my child. I'm not into that gentle. Don't get your butt whooped. Alright, so now, when she backed up and created this graph, what type of slope do we have? With positive and negative. Really? That's a negative slope.
that paper don't get positive.
Positive slope, right? That's
You gotta have your master teacher.
I'm saying, look at that line. Is that a positive slope or negative
Some of
slope?
our budget.
That's a positive slope. You would think when she went away, it would be negative. I got you. I thought the same thing. However, remember what it's graphing. It's graphing her position relative to this particular muscle. So as she moved away from it, her position got greater over time. Her position away from it.
It's negative.
I don't know. You want to try it the most? Let's try it. Let's try it.
No.
All right, let's try it. Let's see. All right, how do we go back to it?
I know, it's, yeah.
This is
All
on
right.
the GI 84.
Okay.
That's
So
fine.
you're gonna start back there?
I like the 84. I think the 84 is easier.
It is.
Way.
84 is easier.
All right, ready?
Yeah.
Okay, hold on, let me hit okay. Okay.
Walk.
Alright, so what type of slope
I
is
did a
that?
couple, I did.
The negative slope. So when we walk, when we walk away from it, we got a positive slope. when we walk towards it,
I would
we got a negative slope, right? And so, of course, the little jagged, we're gonna just disregard the little peaks in our situation. But it's hard for us to keep a constant, you know, it's kind of difficult for us to make our bodies move at the same pace, right? To create that constant slope that we see on the line, that growth pattern, right? We would have to physically, you know what I'm saying, like just mentally prepare ourselves, okay, move very slowly, constantly, right? All right, so let's write some equations based on the graphs that we just created. All right, so what do we need? What two pieces of information do we need?
It's really L, X, and Y.
X and Y's? What do you mean by X? What do you mean by X and Y's?
That's what we got to do our files on this year, that's the always started with.
That's what you always started with, X and Y? Well, what is X and what is Y?
Never mind.
No, talk to me. What is X and what is Y?
Never mind.
Never mind. Come on now. We only got a few more minutes and then I'm gonna be quiet so y'all can actually do some work. You don't want to do no work?
Don't say do that.
No? So what two pieces of information do we need in order to write the equation of a line?
What you think? It's starting right.
What do you think? What do we need?
Wait, what you think?
What two pieces of information do we need in order to write the equation of these lines we created on this cool little motion detector situation?
The growth and the starting point.
Growth and the starting point. Also, now what's another way to describe the growth? Rise over run. What's another way to describe it? Slope. Okay. What's the starting point? On here. What's another way to describe the starting point? Say it again. Why? Just why? Huh? No, not just why. Well, what's another way to describe it? That's the y-intercept, right? It's our starting point. Show it to me on your graph. Now, if we look at this graph, what's our starting point? Okay, you can pick it up so you can see it. I know that angle is a little off. What do it look like our starting point is?
That doesn't, if you have that over there. Nope, you have
I
that.
believe it's 1. 4? Take a look at it.
It doesn't use it.
I was supposed to bring my document camera so I can project what we see on here for we can all see it together. But I left it out this one, so my apologies, guys. We could text them later after this great math lesson that we learned about
This is
these right
for
equations
one,
to these lines.
it's like that.
Yeah, good. So what's our starting point? Alright. How can we figure out our slope? Because you told me we needed two pieces of information, our slope and our y-intercept. So we got our y-intercept, we said it's 4. How can we figure out the slope?
7.5 is a low.
It's not, it's really not. You know how much math I have to share with you? We could do this for hours and hours and hours, like the song say, right? Hours and hours and hours. Come on, guys, get with the money long song and get this math.
You know, back to like the boxes, like the graph.
Okay, so if I gave you
If you get
a graph of a line that had the boxes, you can write the equation for me?
Uh-huh.
Alright, let me do that. Let me do that. Let me do that. Computer. You know what, technology? Don't do this to me today. You said please do that. Y'all are really my students from last year. I love you. I love you. Y'all so authentically yourselves. And that is. Alright, so you told me you needed some graph, you needed some lines, some numbers. I got you. This is what I do. I can do that. Easy. Boom. Let's go. Let's work. Okay, so make it a little bit bigger. So you all can see. That helped us. I promise y'all, sometimes I can do it. Alright, is that bigger? Yes. Alright. So how about I figure out my starting point, my y-intercept. How do I write this equation of this particular line? Cause y'all told me y'all needed some numbers, some graphs, a whole little situation. I gave it to you. Now I need you to give me the equation.
I think it's something about.
So it's 18? Listen here. Told you before. I'm not a gentle parent. Get it together. Hey, you trying up? That's our goal for today is to create a graph and write the equation. So how do we do it? Thing right there. What's the thing now? Help me out over here. That's the what? Starting point, y-intercept. Yes, yes, yes. Do we all agree?
Yeah.
All right, let's rock with it. 18 is our starting point. But what's the equation? We gotta get the whole equation. That's one piece of the puzzle.
Oh, no, it's right here. Never mind.
I see a triangle.
You see a triangle. What triangle do you see? What does that triangle help us identify? The slope. So y'all told me we needed two things, right? Slope, y-intercept. We identified our y-intercept as 18, you said?
Oh, it's 2/1.
2/1?
What do you mean? 2/1.
What's the scale? Is that scale 2?
Oh, shoot. Never mind. It's right here. I'm going. No, 2/1.
Is it 2 though? What's the scale? Each of those little tick marks represent what value?
Alright.
That's a good question.
How did you get this to be 18?
Because it's on the line. It's on the line.
Well, how did you get this? I ain't saying it's wrong. I ain't saying it's right. I'm just asking you, how did you get to 18?
It's on the line. It's on the line.
I didn't see 18. So can you help me figure it out? How did we get to 18?
It's 10 to 20.
It's 10 to 20, but you're counting by what? Oh, so that's your scale. Okay. All right, so now tell me your slope again.
2/1.
Really? Count it again.
It's 30. Can you tell me, please?
No, I'm not gonna tell you. I'm gonna tell me. That's the whole teach and learn thing.
Okay, so
You the teacher.
come up here.
So look.
Not me.
So what? You went 10, 12, 14, 16, 18, 20.
Oh, 16.
Oh! So what's our starting point?
16.
16. Because we figured out our scale is 2, right? Alright, so now, if you went, so from 16, you went up to what? To get to that point, 20. So what's your change? So what's your slope?
4/1. I mean, no.
Shoot.
Right up.
I said 20. I got you. So we went up 4, and then we went to the right how many? So what's my slope?
4/1.
Alright, y'all gotta get with this. I'm about to whip this child. Where is my belt? Let me get a belt.
I was still answering the
Okay,
question.
alright, you about to get whooped. Okay, so we got our 2 pieces of information. Now tell me the equation. And then
Y equals 4 plus 16. No.
y equals what? She told us the slope. She told us the starting point. Everybody write the equation on the paper, or we getting a whooping. Less belts coming out.
Wait, don't 16 don't 16 go at the
I
end.
did not know.
Okay, don't 16 go at the end. Right? It was, yeah, okay.
I got a belt in my car. It'll take me 2 minutes to go downstairs and come back
I'm
up
not going to spend
with it. Everybody write the equation. Put it on your paper.
I mean, it might be wrong, it might be right, but at least I wrote something.
Mama, you write something. Write something down. Write something down. Write something down. So what do our equation look like? What does the equation line look like? Y equals mx plus b, or b plus mx. It doesn't matter which way
16
you write it.
is the starting point, right? And 4/1 is the slope.
So write the equation. So we got all the information we need, right? Yes?
Don't we? Yeah.
Yeah. And you're like,
I mean, do we have to write one though?
technically, no. However, because we know our slope can always be written as a fraction because we wanna be cognizant of this rise overrun. I always write it as a fraction just to remind myself. Good job. Good job. Good job, my problem child. It's always one problem child. It no matter how many kids you have, you always have that one that requires a little more love, right? Let me see what you got. Where your x at? Where your x? Y equals mx
That's
plus
what she had.
Where your x- where your x at? You missing a variable. X, where's your x? It's gotta be next to the slope, right? Y equals mx plus 2. Alright, so listen, I think we accomplished our goal for today, right? So our goal for today was to use the technology to create some graphs of a line and then write the equation. But y'all told me it was a little bit difficult, so we have to put it on the graphs and give you some tangible so you can figure out your slope triangle and all that good stuff. So we good?
We done.
With this part, we good?
We got another part.
It's always word bad. Are we good on this?
No,
Nah, we need some
No?
more help.
Need some more?
no.
I love it. Alright, so let's do some, y'all, now it's time for me to be quiet for y'all to do some practice.
I like that.
I don't like that idea.
You don't like that
I don't
idea?
like that idea.
I do.
Alright, listen. This is cool. Okay, let's do this. This is a really cool situation on this little technology.
I don't know about your idea.
Where you have to-
Cool.
What? Just rock with me here, okay? Just bear with me, ma'am. So they're gonna give you the graph and then you have to mimic it. You have to create the motion to create the graph. It's called match my line.
This your game. This your
I
game.
did not invent this.
She probably did.
I did.
Kira,
She thought it was
If I did, I wouldn't be here right now because I'd be a millionaire. So I'd be, chilling on my yacht right now. But
use this before.
The studio.
so let's do that. Y'all wanna do that? We just gotta get up and
Did they say my name?
create the situation. No, they did
I
not
think
call
they
you.
said mine. I think they said my name.
I think they said.
I just gotta figure out where it's at on here.
I heard at the end.
Huh?
I heard at the end.
Yeah, Zaria.
Yeah, but not yet.
No, not you all. Y'all stuck with me for a few more minutes. I only got about 15 more minutes.
I think I should go check.
Yeah.
Alright.
Shut up.
I've seen CP experiments, but I don't know if that's a special CP now, user agree. It says to look at the very beginning of.
I'm trying to fight with sleep and I
Keeps
can't.
on
Use these.
texting.
I'm the one that's fighting that.
Do you know how to get to the match my line situation?
No, I didn't know it was available on here.
I don't think so. I don't know. I remember it was under a good person to ask when David Sword.
No?
Yeah, distance match. Distance match.
Yeah.
That's the best.
One thing that Jen has used when she was teaching calculus, she used
Selected function will open okay. Try to match the graph on the next
here we go.
screen. See? Two
You guys
brains are definitely better than mine, right? Alright, let's get up. Everybody get up. Let's all try it. Let's all try it. I know. Come on, shake your bodies.
So I think when you get next, I think it automatically goes.
Okay. Yep.
Okay.
So we gotta match that.
Oh, wait, how many feet away am I supposed to start then?
Guys, come on, guys. Come on. Let's. Tail, feathers, everything is in it.
9 away. 1, 2.
Y'all having too much fun.
This is what we do.
You just being a hater.
In on it.
Okay, you guys should tell me when to like stop and tell me which way to go.
Right.
Because I don't know.
We
So
gotta do it.
It's a negative slope, so should she be backing away or should
Yeah,
she
do I
be
go-
walking
do I
toward?
go further that way?
Wait, but like, what
So
if the
that might-
teachers or adults do that and then we just be like, you You gotta move up, you gotta move back.
That's fine. That's
Alright,
fine.
cool.
See, compromise. I love
I'll
this
be
compromise.
your little whatever, your
And then y'all gotta
cursor.
help us though.
I'm your little cursor. So you gotta tell me where to go, because otherwise I don't know
That's
where to go.
time. So look, that's time on your X. So that's 1 second, 2 seconds, 3 seconds, 4 seconds. Right?
But which way do I
This is
go
me.
first?
Which way? Should she be walking toward? What's her starting
And
point?
actually
What's the starting
where
point on here? 9 feet, right? She's starting at
Do
9.
I get further away or closer?
Should she be walking toward the situation, the motion detector, or away
Go
from it?
back. Ain't that forward? No, that's forward because it's going down, right?
I don't know. You tell me.
Mom, what the compromise was, you got to
I will assist. I will assist.
make it go.
Alright, so if
Wait.
we hit start, should she be walking toward the machine or what?
Wouldn't it be forward because the line go down, right? No, I don't know.
Yeah.
Yeah.
Okay, so,
Let's try it.
okay, so 2 people say go forward. Baguette, what do you think? Forward? Okay. You guys, am I just going forward? Is it the
You
straight
go
line?
forward. No, you stop.
You're gonna tell me to, and when you tell me to go the other way, cause I'm remembering like a few different segments to that thing, right? So then you're gonna tell me to go away a little bit, and then you're gonna tell me to come back, or what?
Also, yeah, go back and.
Okay, so, but I'm gonna start out going
Go
towards
back
it.
to 2 feet.
Okay, you guys tell me if I'm doing it, if I need to go faster, if I need to get,
Stop
okay?
at 2 feet.
About, okay.
Don't hold me though.
At
Hold
2
up.
feet or 2 seconds?
Wait. Don't start. Can you make sure we right?
You know what?
I wanna make sure you practice. My job is not to make sure you right, my job
Yes,
is to
it
make sure
is.
you practice, so that you know you right. It's not
You
about
think
me,
I'm right?
it's about you. Y'all agree?
I think you got a lot of good ideas you're not giving yourself credit for.
I think you should teach this lesson. So when I teach this lesson next year, I'm gonna have you come in as my guest, teacher and go ahead and razzle dazzle the class. Okay? How much time does she have to move that distance? Each tick mark is a second.
It's in the middle.
Okay.
Between two. Stop at like 2.5.
2.5 seconds?
Really?
So like
No.
1,000, 2 1,000, up,
Yeah,
and then I just stay there?
And then go back.
Go back.
Yeah.
Should she walk fast or slow?
Yeah, how should
Doesn't
I be
matter.
walking? And I've just lost.
Does it matter?
Does it matter? Does it matter?
This is about
Does it
9.
matter? Y'all wanna just try it and then
Let's try it, guys.
let's try it and then we'll tweak it.
I
as we go?
promise you guys will get better as you keep doing it.
Alright, so she's gonna walk. How fast or how slow? What we gonna walk? Fast for a minute?
They
I mean
can
for a
find
second? What we doing? What we doing?
Go
What's stopping it? Go
Go
slow.
Alright.
Wait,
Until-
do it like it's fast?
Go slow. So she approaching the monitor
That look
For-
like it's slow.
almost 2 seconds. Then she's stopping and then going which way?
Okay.
Then back it up,
So
back it
go
up.
forward. When you're going forward, walk fast. When you're going backwards, walk slow.
Okay. Okay. Let's
All
try
right.
it. We ready to try?
I'm scared.
Ready?
Ready.
Ready. Let's go. Now we see that? Did we match it? Okay, so how will we change her motion in order to match this graph?
When you walking backwards, go. Yeah, go slow.
When she sped up, what happened to the line?
It went up.
So my pace was pretty good the first part. I did okay the first part. Did it match in the beginning?
Yeah.
Cool.
We had a
Cause I don't know. You guys, I'm dependent on you guys.
Okay. Now, but what we need to do next?
Go slow when you're walking back.
About the
That's
same.
welcome
Do you think
back.
I should go about the same as I'm going back? Okay, I'll do it again.
Come on, you gotta help us out. We need your help. We need your input. Your input is valuable, and we need it. So we're gonna try it again. Let's retry. We're gonna retry. So what's the directions we need to get?
Go forward, then go back. You go forward, walk slower.
Slowly and slowly.
Slowly and slowly. We ready?
I think so.
All right, let's retry.
Doesn't sound like it's kicking yet.
Okay, I didn't get started. My part, my bad. All right, did we change? Did our graph change?
Man, that's some
So we good on the first part. We got the first part down pat. What do we need to change
Walk
about
to
the
the
motion?
side, walk to the side. I don't know.
If you step to the side, are you gonna change?
No. Walk, keep going forward.
If you keep going forward, is your line gonna be in the right direction?
That's
So as she's coming forward, we got a negative slope, right? So we know she gotta back up.
Wait, go
To
go
create a
slow and you
positive
go
slope.
fast, or go fast and go slow.
You think that's gonna change? How do you think that's gonna affect it? So, you look at her, look at the line she created, right? She walked at the same pace coming toward the device, and then she stopped, and then walked the same pace in the reverse direction. Let's look how our graph changed. We need your input. We need your input. We need your eyes, ears, everything. So what do we need to do in order to flatten this line up? What do we need to do?
She went slow and she went fast. What's the
She didn't go slow and fast. She went the same speed. She went the same pace.
No, I'm talking about the first time she went fast and no, she went
I went slow.
she went slow the first time
And then fast back.
and then fast back.
That was on the first try.
Right.
Let's
And
throw
then
the first
second
try
time
out the
she
window.
went slow and slow.
Right.
The first part is right.
The first part, we got
That's
that
the
now.
first part right there. That's the
Exactly.
second
We almost
part.
matched it.
So
What do we need to do to match that second part? You gotta run back.
she got to run.
Really?
A backwards run, a backwards jog.
I can do that.
Y'all think that's gonna change it?
No.
Come on. We
Oh,
need you.
okay.
We need,
Come on, girl.
okay, let's retry.
Come on, y'all ruined it.
So what's the directions? We gotta get clear
For real.
directions to our lovely participant.
Wait, cause you keep saying we gotta get clear instructions. Like, why you keep trying to change it? Is you trying to change it? Is it? Can you give us a little hint? Like, cause now I'm
No, I cannot.
Girl, if you'll just try it.
I'm saying, in order for our lovely participant to do what we're asking, we have to give her clear directions, right?
right. So that's my clear direction.
No, I'm just asking you to. I'm asking you to tell her what she.
How is this gonna be different from last time? That's my
Exactly.
question.
Exactly.
Yeah, let's do what she said.
Let's do what she said. What did she say?
Go slow, coming forward, and then run back.
Jog backwards.
Jog back.
Okay. Okay. Let's try it. We ready?
Ready.
Retry. And start.
That's the best I can do with jogging because I was trying to keep facing. I got to
Wait, hold on, wait.
Hold on. Okay.
Uh-huh.
Okay.
All right.
All right.
There we go.
We got action.
I'm not doing that. No second.
We got action. We ain't did nothing yet.
Go slow, and then she ran back instead, and then she walked fast back.
What part of the graph represents her change in speed?
What?
What part of the graph
trying to make me.
represents her change in speed?
That little thing right there.
What little thing right there?
What is that?
I don't know. I'm asking you.
What is that? I'm asking them. Which one?
What do you point to?
Right here. What's that?
Take a look at the
She
graph.
says a change in motion.
What part of the graph represents her change in her pace? When she went slow, when she sped up. Show me where do you see that on the graph? Where do you see that?
Right here. That thing right here.
So look at that first portion. She was walking, right?
Walk slow and then go fast.
But then look at that. How when she got faster, look how
starting place down.
what changed.
Walk slower? Are you telling her to walk like a little snail?
No, I'm not telling her anything. I'm asking you a question. She walked at a steady pace, slowly, right here. Then she sped up. You see how that slope is kind of
Wait,
faint, and then you see how this slope is steeper.
right here. So
Maybe she gotta,
right. She came upright.
she gotta turn.
Do she gotta turn?
If you turn, what's gonna happen?
Does my position change when I turn?
You mean like turn her back and go the other way?
No, like
Change where I am.
turn.
Like
go that
turn
way.
and go this way?
Yeah.
You think
It's
it's
not
gonna
gonna
it's
reach.
not it's not gonna pick
Yeah.
up? It's not gonna pick up, right? So what do we have to do to
Whoa.
what do we have to do to flatten this line out?
You don't know if I was asleep.
That's
Walk
not-
slower. Walk like a turtle.
Y'all know
Walk
stop
like a turtle.
bothering me.
I don't know.
Okay.
Look at the graph. You wanna walk like a turtle?
But how she gonna
Alright,
already
so I gotta go.
she walked backwards, then she ran
Okay,
right.
okay.
The grass was
So
How should she walk?
I got the first part. We got that down. We got the
first
first
part.
part. Then
That-
for the
I
next
was
part,
just
I'm gonna
talking.
go in turtle mode.
I
Okay.
don't listen because y'all think I'm wrong.
Okay, I think I know what that means.
All right, we ready?
Give it a try.
All right, let's go. All right, you ready? Start. Turtle mode.
How'd we do?
Better.
Better? Was it the way we wanted it to go?
Mhm.
Oh, wow. Oh my gosh, there's like one other little change
Well,
there.
what happens right here on the end?
What does happen there?
What does she need to do to match that part?
Wow.
Go fast?
Really?
No?
I don't know.
Yeah, cause it's going down.
Now what?
No.
What made it go down?
What made it go down the first time?
Walking
I'm
slow.
walking slow.
Really? That's what made it go down?
But when she ran, it
Walking
went
like a
up.
turtle. Oh, what?
What did she do
did
first?
Go down. She went forward, walking.
Oh, so she
Also
got
go
a-
forward.
Ah, so she. Okay, all right. Now we cooking with Crisco. Now we gotta add a little butter to it. Come on with the seasoning.
I said go slow and then go
Now
fast.
we need a little seasoning salt. Lawry's, we need you, sweetheart. We need a little Lawry's. Lawry's,
Look
black
back
pepper.
at that, cause
onion
when
powder,
we
garlic.
first started talking, I was like, go slow, then go fast. I'm gonna need you to show them that though, cause I don't want them to think I'm lying. You got that.
But what changed the direction of the line? How did the line went? So
She went back.
at one point we had a negative slope, then we had a positive slope. Now we need a negative slope again.
She
What
went back.
changed? What motion?
Her motion, her change
Slow,
of
she
motion.
went slow.
Yeah, she went like a turtle.
Really? Turtle mode changed that? Changed
No.
What changed it?
Then she went backward.
That she went backwards versus going which way?
So I went forward,
Forward.
and then I went backwards.
Okay, so now what do we need to do in order to get that last part?
Yeah, I can sleep. and
Go
sleep
forward.
with you.
Girl.
She came forward, she went back,
So I gotta change one more time.
and then what do we need to
Go
do?
forward.
Go forward again. All right, so
Alright.
forward,
Check that too,
back.
I said it.
All right, okay, let's go. Let's try it again. Y'all ready?
I think so.
So we need to give clear directions. What's our directions?
Forward, backwards, forward.
But,
At what
Okay.
point do she stop?
So, wait, back there?
how do I know when to turn that last time?
How do we know?
Will you guys tell me? Can you guys just shout it out?
Wait. We gotta get a little, we need a team break thing to get in.
Okay.
That's how she was going forward. So, where did it stop? I'm confused. Right there.
What's on your x-axis?
Like right here.
What's on your x-axis?
Go backward. So it'll be right there. Somewhere between there. This is going about 5 or something at the bottom. What is it
This is
going about?
one.
Oh.
At the bottom or something?
Yeah, I think this is one.
Like 3:45? Something.
Okay.
Don't pretend like you have your house on water here. I was just answering the question, so stop bothering me. I said come here. I'm bothering you. That's good.
So what we doing? Walking forward?
Forward, backwards, forward. So we gotta figure out where she stopped and then come back forward.
Okay.
Y'all both
But we don't know where she let us come back.
So use your time. If that's 1 second,
I'm marching some
1.5 second, 2, 3, 4. So where's this peak at? Like after about what, 3 seconds?
3:20, like 3:22, 3:22.
So like right after 3 seconds, she needs to be going in the other direction, right? Yeah, go ahead, sweetheart.
By the time I get back home, I'm gonna
Nope, we're gonna do
So
some more
wait,
math with you.
okay,
Just for you, we're gonna stay extra hour. Just for you.
Everybody or just her?
Just for her. Just for her. Y'all just go to y'all next class.
Alright, I'm being here.
You gonna get some one-on-one intense math love.
You can
okay?
ask Bughead about that. He was that
Listen.
person yesterday.
How was it? Wasn't it awesome?
No, we
Then you
wrong.
got, then you got you got tag team, 2 teachers. Listen, you got
You got
awesome.
But listen, that's big cat. I don't wanna do that.
Ain't about what you want, it's about what you need, girl.
I'm
All right.
outside.
We ready? Y'all give directions? What we gotta do?
Forward, backwards. When you get like a little bit after 3 seconds, and going backwards, come back.
Okay.
Forward.
And do I stay kind of slow at the end there? I mean, I think I go a little faster in the beginning and then I do snail mode. Am I snail mode to
Turtle
the end?
mode. Good?
Turtle mode, yeah, that's
We
what
didn't
turtle
think
mode.
that through.
We didn't think that through. Okay, well, let's
Alright.
take a look at it.
Well, let's just try it.
We got like 2 more minutes, and then we gonna do our last run, and then we gonna start our one-on-one intense
No,
math.
we not.
Yes, we are. That's how much I love you, child.
No, serious.
Listen, I'm gonna go with you. We're gonna just do this math together, okay?
But you just said she could see.
Miss Ricker said we could do
Uh-huh.
She gonna do math too. We can all do math together.
She loves math.
We ready?
I don't.
We ready for our last run?
Okay.
All right, let's go.
You are too happy with this. What's happening?
I mean, kinda. I mean,
We got
We're
closer.
getting a little.
We're
At least we got
closer.
the 3 segments in there, eh?
Ah.
So I needed to slow down more, looks like. Because it looks like the flatter that line is.
Can I try?
Yes!
Come on with it.
Y'all go to sleep?
No, you can try. Yes on the first question, no on the second question. Come on.
Come on.
Come on, move your tail feather. Let's go. Let's do it.
Right here, here's the starting
Come
point,
on.
right here.
Let's
Come on, let's
Come
do
on,
it.
girl.
Come on.
Let's go, Zaria. You can do
So,
this.
Corey, you watching me like a hawk.
About to come over there. Yes,
Let's
ma'am.
do it.
She can't wait to be
Start
up.
point right here. This crack right between these 2 tiles is 9 feet. It's for you. There you
Alright,
go.
good.
All right,
You
take
ready?
it. I'm tired anyway.
You ready? Y'all give her directions. What you supposed to be doing? Come on, group. Come on.
you go.
Well, I woke up before he went in there.
You listening?
You
Okay.
go forward, walking. What was your pace?
Like medium.
Walking medium. I know what it means. Like kind of slow, kind of fast.
Yeah.
Walking back, and then you walk back,
Turtle.
turtle,
Back, walk back on yourself.
walk back, slow.
Or just turn around.
Not just walking back.
Yeah.
Backwards.
And then that's it.
Walking slow, and then come forward when you walk forward.
Slow. Yeah, I should have been slower on both
Slow
of the
work.
last ones, I think.
Yeah. Slow motion.
Just let me know when they go.
Alright, you ready? Let's go. Back. Then what? Give us some directions.
Wait, what's that crap look like?
We almost got a parabola in here.
Okay.
We almost got a
Yeah,
parabola.
look at you nailed that beginning part. You just went a little too far.
Nice.
Nice.
I walk in the class.
Alright. So listen. Our goal for today, right? Our goal for today was to use the technology to make sure we understood how to actually write the equation of a line based on the graph.
Just walk them up here.
And so this last piece where we were actually just experimenting,
Zaria.
making sure we understood the components of a line and how that translates to the graph. So you see how her speed, her change in speed represents the slope, right? Her pace, her rate of change, that represents the slope. That's how steep our line was, right? Whether it was positive or negative slope was her coming toward the device or walking back from the device, right? And we know the starting point, the y-intercept, is where you start. Alright, so this makes sense? Alright, so tomorrow, you guys are gonna use this information to even go deeper in this particular investigation on creating the equation of a line based on the graph. Alright, did I do a good job? Thank y'all so much for participating, I appreciate all of your efforts. Thank you so much. Yes.
See, it was fun, wasn't it? I'll take that.